So when we talk about the properties of amines as a basis, right, we have to note down a very important portion over here, that what are bases as per Bronsted Lowry? Proton acceptors. Huh? Understood? As per Lewis acid base theory, right? Lewis acid and Lewis base theory, Lewis acid base theory. Just give me 1 minute. Huh? Thank you. We know this part, that amines uh, can be defined as bases by two ways. Bronsted Lowry and Lewis acid. Lewis acid base theory tells you what? That Lewis acids are lone pair acceptors and bases are lone pair donors, right? In the A level exam, you will be seeing that lots of questions will be there like this. See, lone pair donors. Can you see this? So this defines as a Lewis base. Bronsted Lowry also it's satisfied, right? It's a proton acceptor. Can you see this? Now the main part you have to know that whenever we are seeing amines, right? Amines will be having what? Amines will be having a salt form after acid base reaction. Base plus acid gives us salt and water. So a salt will be there. Now here's a very important question, interesting question on your paper number 3 also, which comes, right. See, phenylalanine is not soluble in water, right? Indeed. Past paper question I've discussed, not soluble in water. On the other hand, if you see the salt, see, we have got iron over here, right? So like dissolves like dissolves like. So this will be highly soluble in water, right? Because this becomes a huge polar, right? A full positive charge or full negative charge is very huge polar, right? Rather than delta minus and delta plus, right? So it will be a water soluble ionic salt, right? Indeed. Now, going to the part, the reaction of the amines, they will be reacting as an acid and a base reaction, right? We know this. Now, when we see that, that if you see a particular the base strength, right? Here we have to know the Lewis acid base theory. That will be better for you. What is the Lewis base tells you? Lewis base tells you that these bases are lone pair donors, isn't it? Now think of this. If this lone pair of electron is easily given out, if it lone pair of electron is easily given out, right? Isn't it fine? Easily given out, right? Isn't it? This will be this will be acting as what? This will be acting as a more supportive base. Is it clear? So that's a very important part. We know that if the lone pair of electron is given out more, right? Isn't it fine? Easily, that will be a better base. This part you have to know, right? Lone pair of electron, if it is given out more, it will be a better base, right? Isn't it? Now come to the part, if you see that when we are talking about this portion, right, we have to know about the inductive effect. As I discussed in the alkene chapter when I was doing with you all in the A levels part, that Markovnikov rule, can you see? We discussed in the nucleophilic substitution in the AS level and alkenes in the AS level. That alkyl group has got two important features. What are the two important features? Write down this. It is a very bulky group, right? See, many humans have got a disease, right? They have got obesity. Have you seen huge obesity? So alkyl groups are huge obese, right? Second, the alkyl group will be having a plus I inductive effect. Note down this, right? Inductive effect. So this thing you have to master, right? So alkyl group will be having a plus I inductive effect, number one. Number two, they will be having a electron electron pushing effect away from itself. So it's very simple, right? That if you take a primary amine, only one electron pushing effect will be there. So that will be having more electron density over here. So it will be easily giving out this lone pair of electron. Now, if you have got a secondary amine, right? If you take a secondary amine, if you take, it will be having more, right? I'm going to this page. It will be better to for you to understand, right? Wait here, huh? See, now listen to this, right? Lewis acid basis theory will be coming in great help, right? Easy, it will be releasing this lone pair of electron, or more is the electron density easily available will be towards the hydrogen, right? So here only one alkyl group is there, right? Here two alkyl groups is there, right? Clear? Understood? Now here three alkyl groups are there, right? Isn't it? So if we compare all these, right? All these, right? The more better nucleophile will be in this order, right? Clear? Note down this, right? Clear, everybody? But on the other hand, if you take a phenylamine, We learned in the chapter of benzene, right? That if benzene has got a minus I inductive, if you note down this, right? We learned that NO2 benzene has got a minus and inductive. What is minus inductive? It will be pulling electrons towards itself, right? Is it fine? When it pulls the electron towards itself, what happens? The lone pair of the electrons will not be easily available over here, right? Is it fine? So this will be the least basic. Over here it will be coming, right? Phenylamine will be coming here because it will be pulling away the electron pair over here, right? So that's a very important part. We know that whenever we are talking about the strength of the nucleophile, right? So the strength of the nucleophile will be very, very important, right? You need to know about how the electron pushing and how the electron attracting things is happening. So phenylamine is the weakest and ethylamine will be the strongest, right? And this is a very important portion which will be coming in the linking with the bonding chapter of AS level. See, they're saying that write the equation for diethylamine reacting with hydrochloric acid, right? Suppose there's a question over here, right? See, dimethylamine reacting with hydrochloric acid. What we do, we say that dimethylamine plus HCl gives you the salt, right? We are getting the salt, salt plus water, right? So I understood this part. Salt plus no, only the salt we are getting, not water, right? Because you have hydrochloric acid only, right? And amine is there, right? Name the product. See, it will be something like this. I'm going to this part. It will be what? It will be, suppose you are taking dimethylamine. So dimethylamine will be this. If you take this, this will be N methyl methyl H, right? So this will be attracting the H plus and will forming what? Will be forming dimethyl ammonium chloride. Clear? Dimethyl ammonium chloride. Is it clear? Fine. Is it clear? So that's a question answer we are getting, right? Now see second question. Phenylamine is not very soluble in water, right? Isn't it? Predict what you see if you add concentrated hydrochloric acid to a mixture of phenylamine in water. We are seeing that, we'll be telling that the oily layer will be slowly dissolving because what happens? The hydrochloric acid will be reacting with the phenylamine to give you the salt. The salt will be highly soluble, right? Isn't it? Isn't it? Now we have to know this also, that if you add sodium hydroxide to the salt, see, I'm coming to this part, right? If you're adding sodium hydroxide to the salt, this partner, if you have the book, please open this book. If you add a sodium hydroxide to the salt, what happens? Sodium hydroxide will be pulling out this, right? This hydrogen, right? This acidic hydrogen, right? And it will be giving you the phenylamine plus water plus Cl minus, right? So again, the phenylamine will be generated, right? Isn't it? Isn't it? So that's the way we do. And that will be coming to this answer over here, right? Clear? Understood this part, right? Just 1 minute, guys. Now see now, if you see when you talk about the particular phenylamine, right? So phenylamine, if you see, will be the weakest base, right? It will be the weakest base. I told you why. The availability of the lone pair of the electron will be very crucial, right over here, right? Isn't it? Now going to this part, we have to say that if you see that whenever we are seeing the reaction, right? The reaction will be also very important to know that how they act as nucleophiles. We learned just now that the nucleophiles will be as per the availability of the electrons, right? So I'm just doing another video.